Hello and welcome back to Algebra 2 videos. This is a video over Section 9, which is called Rate of Change. And what we want to accomplish today, our objectives, is we want to calculate the average rate of change over a function, over a specified interval. Part 2 says we want to interpret the average rate of change of a function over a specified interval, and then we want to solve problems involving direct variation. So, when we think of the word rate of change, oftentimes we think of the word slope, okay? And when you think of the word slope, usually that means the phrase rise over run, okay? Also, rise over run, some might think of it as the change in y divided by the change in x. Okay, others may think of it using the slope formula given 2 points as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then while others in a Algebra 2 class or pre-calc or even calculus can use the difference of two function values, so f of b minus f of a over b minus a. Okay, all of these things represent the same thing. Rate of change, slope, all that kind of stuff. And a lot of times, when we think of slope, all right, when we think of slope or rate of change, slope slash rate of change, then we often think of, it's a measure of steepness, okay? So it's a measure of steepness. Okay, and we apply a value to that. And usually what you get, you can either have a positive slope that goes like that, a negative slope that goes like that, a slope that has zero slope, or an undefined slope that goes like that. So what I want to do here, here's just an example of different slopes. Okay, this is a slope of 1, this is a slope of about negative 1/2, and this is a slope of about, I think, what is that, 3 or 6 over 2? Yeah, something. Okay, in any case, all right, what I want to do, and it gives us this actual definition of rate of change. It's a ratio of the change in the dependent variable with respect to the change in the independent variable. Remember, dependent, that's another word for us to say y, change in y, over the independent variable, which we will call x, okay? So a line has what you call a constant rate of change, meaning that the slope doesn't change, okay? The rate of change of a line is its slope, okay? And we can calculate the slope over here, between these two values, and what we would do is we'd find the vertical change, so the change in our y from point to point versus the change in our x. And I should probably, okay, we're good on that. And so our change in y, to the distance of this stair step, okay, this vertical change is going to be a change of 4. Okay, and a horizontal change is going to be a change of 1. Okay, and so what we'd say here is if we wanted to talk about the slope of this line, then we would say that the slope is 4 over 1. However, we have an actual value for what x means and what y means, and the y value is distance. So what we get here is we get 4 miles per 1 hour. So miles over hours, so 4 miles per 1 hour. Oh, look, that's a speed. That's 4 miles per hour. Miles per hour. Okay, so when you're talking about a speed, all right, that's a speed, all right? So whenever you're driving in a car and you're looking at how fast you're going, well, folks, that's a slope. That's a rate of change, all right? So when I love the shirts that people saying, it's like, oh, another day goes by where I didn't use algebra. Well, I'm sorry. If you drive in a car, then you're always using algebra. You're always using calculus. It's what's happening, and we have to embrace it, and we have to enjoy it. We have to have fun with it. Okay, I digress. Hopefully that makes sense to you, but that's pretty cool. Okay, so all right. So let's take a look at what we've got here. All right, let's just the ability to calculate the slope of a line. then what I do is I take 2 points on a line and I calculate the vertical change divided by the horizontal change. Okay, and remember that slopes can either be positive, going this way, they can be negative, going that way, they can be 0 if they're horizontal, and they're undefined if they're vertical. Okay, so because we are going this way, that means that we're going to go negative. Now, you can even think of it like this. You know, you can go down 1, okay, going down 1, and then to the right 2. All right, so the slope, m, and we denote slope as the variable m, is equal to -1/2. And that's it. Okay, that's all I'm doing. Okay, and what's the slope of line P? Well, you know, we can do this a number of ways. You know, we can go from one point to the next and go talk about our vertical change and then talk about our horizontal change. And so our vertical change is a vertical change of 2 with a horizontal change of 3. Okay, and because we're going in this direction based off of our picture here, means we have a positive slope. Okay, so if I wanted to discuss what our slope m was, it'd be a positive 2/3. Okay, now do you have to just use these points? Could I do other points as well? Could I even like go down and over? Sure. Okay, it doesn't matter. You know, still a vertical change of 2 and a horizontal change of 3. Okay, and you could even go from, you know, this point all the way over to this point. Okay, now this vertical change is a vertical change of 4. Okay, and this other horizontal change is a change of 6. Okay, and so even if you wrote this out as the slope is equal to 4/6, this fraction can be simplified and be rewritten as 2/3. So it doesn't matter which ones you use, it just depends on whether you use rise over run or the change in y divided by the change in x. Okay? All right. Now, a line that goes through the origin is called something that varies directly, okay? A direct variation, okay? And a direct variation has the form of y equals k times x, where k cannot be equal to 0, okay? And k is called the constant of variation, okay? Mainly what it means here is that you've got y equals k times x, and that k is your slope, okay? That's the idea, all right? You can get all this crap about constant of variation, and you can get really technical, but if you know something varies directly, you know that it has a linear relationship and that you have this constant k, and normally you would use the variable m, but if we say that it varies directly, then we use this constant k when that means slope, okay? Okay, let's take a look at the problem on this next page. And what this says, it says find the ratio of book price to the number of pages for each ordered pair. Round your answer to the nearest hundredth. So what I'm going to do, what they do is they say, you know, here's the number of pages, here's the price of the book. So, you know, if you think about that, if you take the change in y divided by the change in x, that gives you the price depending on the pages, the number of pages. All right, so the price per page, basically. All right, and so what they do is if you have a book that is, you know, 100 pages, and the cost of that book is $5, then if you take 5, okay, this number here, 5, and divide it by 100, then you get 0.05. Okay, and that would be the cost per page. Okay, so here's what we've got. Let's see what happens if I have 400 pages, and the cost of the book is 20. So if I do 20 divided by 400, oh, look! I get 0.05 again. Huh. It's pretty cool. All right, well, let's check and see what happens here. Okay, if I have a book that's $6.25, and I divide that by 125, then, oh, for God's sakes. Divided by 125. Oh, look, I get 0.05 again. Okay. If I take the value of $15 and divide that by 350, okay, if I take $15 and divide that by 350, oh, man, then you get about, and it says round to the nearest hundredth, so that's 2 decimal places. So this actually gives me 0.04, okay? And that's the cost per page, all right? So A is 0.05, B is 0.05, and C is 0.04, okay? So let's take a look over here. The ratios are virtually the same, okay? And we're talking about a cent here, not really that big of a difference. Therefore, the points in the table form a direct variation, okay? And so, you know, if you had 0 books or 0 pages, you would have a price of $0, okay? And that's the idea. All right, let's take a look at the next one, okay? So a lot of these things, all right, so let's take a look. Based on the graph shown to the right, okay, here's our graph. Oh, cell phone phone plan costs. You've got the cost as your y-axis, and you have time spent talking in hours as your x-axis, okay? So based on the graph shown on the right, whose phone cost varies directly? So which one of these goes directly towards the origin? And that's, oh God, what is that, Nikia? So Nikia's phone, Nikiya, Nikia's phone is the one that cost varies directly, okay? And says that Mark's cost does not vary directly with the time spent talking because the cost for Mark to initially, you know, just have the phone, because he has a $20 upfront fee. So without even talking, he's paying $20, okay? Now, Nikia, she just pays for however much she talks, okay? But notice that her rate is a little bit higher. Her line is a little bit steeper than Mark's cost, okay? So Mark has the $20 initial fee, initial cost, or initial fee, whatever you want to call it, okay? Then it says for Nikia's plan, the value of the constant of variation is what? Okay, and what this means is we need to figure out, you know, the slope of this line. The constant of variation, remember, means slope. So if I take our vertical change, so I'm going to go $30, and that's for 2 hours of talking. Good Lord. All right, Nikia's plan is in blue, so that's $30, okay, and that's for 2 hours of work. So what we can say that the constant is, you know, the slope is, I'm sorry, let me do this, $30 per 2 hours, okay? If you simplify that, then you get $15 per hour on the phone. That is a lot of money. So So we get $15 per hour, okay, which represents her hourly cost, okay? That's quite a bit. That's ridiculous. Hopefully they've got a better texting plan and that she's not talking on the phone a whole lot. That would be rough. All right, let's take a look at this. What this wants us to do is we, you know, think of a, you know, company sales, all right? And as time goes on, depending on the week, depending on the time of year, sales can fluctuate, okay? So, you know, we make pretty good sales within the first week, and then, you know, second week it kind of gets levels off, and then third week, we go down quite a bit. But then we shoot back up again and go down, and we kind of hover, and we're just kind of just chilling right here, and then all of a sudden we go up, okay? So the thing of it is that if you were to calculate, you know, each one of these slopes, you know, it would tell you a story as far as, you know, what's happening with this, you know, with the company's sales over time. How much sales do you make per week? And so what we want to do is, you know, we don't necessarily look at all of these points and we'll look at what's happening every day, but we look to see what's happening over a period of time, okay? Because we're going, okay, you know, over a 6-week period, we're going to have highs and lows, okay? We're going to have maximums and minimums. And let's see what happens over the course of time, okay? And so what we call this the average rate of change. Average rate of change, okay? And so because, we're talking about an average rate of change, that means that the slope over a time period. So what we want to do is we want to calculate the slope from the very initial point to the very, very end, okay? And I'm just going to go ahead and draw a vertical change, which is $140, okay, 140, divided by the run, the vertical change, the horizontal change, which is 6 weeks, okay? And so even though it fluctuates, over time, the company has made money, okay? And so on average, we want to know how much are they selling per week. And so what we can do, okay, to find our slope, and we'll call this M, all right, we're going to take $140 and divide that by 6 weeks. Now, let's actually calculate what 140 divided by 6 is. And that has a value of $23.33 per week, okay? And that is our average sales per week. So that's our average weekly sales, okay? And that's what we're looking for. We want to just look at something like this and say, all right, well, how fast, what's the average speed that they were traveling, or average, whatever. All right, let's take a look at the next one. Okay, so, and when we use this thing, average rate of change, okay, between, to find, the speed of a runner, for example. Now, what happens is that, when the runner starts out, they might be running at a very, very fast pace, as they start out, and they might level off, and they might get faster again, and they might level off again. So this isn't a constant rate of change, okay? So it's kind of hard to describe what the runner is doing or how fast they're going if they're not running at a constant speed. They might speed up, they might slow down. So, but the point is that we want to, to find the average rate of change, we choose 2 points, and then we draw a line through those 2 points, and then we calculate the slope of that line. Okay, much like we did in the first one. So I'm going to do that same thing. I'm going to pick our very, very first one, all right, and then our very, very last point, okay? And I'm going to draw a line that connects those 2 points, okay? Now, there are points at which that the runner is going faster than this and points where it's going slower, so it should kind of average out. It should kind of give us a reasonable depiction as to how fast they're traveling. So what I'm going to do is I'm going to calculate the vertical change, which tells me that they ran 12 miles in a 2.5-hour period. So we ran 12 miles in a 2.5-hour period. So the slope of this line, M, is equal to 12 miles divided by 2.5 hours. Okay? And so if we divide those two numbers, and we take 12 and divide it by 2.5, then that's going to give us that the runner was traveling 4.8 miles per hour. Okay? Now, this is an average speed. This is not how fast they were traveling. This is an average speed. Average speed. Okay? And that's the idea. This is so much fun. I love doing this stuff. This stuff is great. Okay, last one. Now, we did that on for the first, what's it called? The whole time frame. But what if we wanted to kind of say, all right, well, what's the average speed of the runner between, say, 0.5 and 2 hours? Okay, right here. Let's say we wanted to calculate this rate of change, okay? And so we would take our vertical distance. Let me change colors, go back to red. And vertical distance of 6 miles over a horizontal distance of 1.5 hours, okay? So if I took 6 divided by 1.5, then that's going to give me, all right, hold on, let me calculate it. 6 divided by 1.5. means that the runner was traveling 4 miles per hour on average over that time period, okay, which is a little bit less than what we had previous, okay? All right, what about between 1.5 and 2.5? What if we calculate that average rate of change? Okay, and that average rate of change is from 7 to 12, so 5 over a 1 hour period means that they were traveling 5 miles in 1 hour. So they were going 5 miles per hour. So the runner can change speeds, okay? So it says, based on these results, the runner ran at a rate between 0.5 and 2 hours. Okay, so which one ran faster? Okay, the later one seemed like they were running at a little faster pace. Okay, so the rate between 0.5 and 2, this rate, okay, was slower than the rate between the other ones. So the rate was slower. Okay. All right, next question. It says, find the average rate of change of the function on the interval from 4 to 9. Okay, so this is where the formula comes in, okay, of doing f of b minus f of a over b minus a. Okay, that's equal to our slope, okay? Where we have an interval, okay, our interval goes from A to B, okay? And so an interval from A to B, these are x values, okay? These are x values. And so let's go back over to the problem, and let's take a look at this function. And we've got the function f of x is equal to the square root of x plus 1. And so that's just the square root of x shifted up 1 unit. And so we have, what is that, 4, 3. So we've got a graph that looks like this, okay? And, you know, and it kind of goes over like that. And it wants us to figure out the average rate of change over the interval between 4 and 9. So here's my value of 4, okay? And then if we continue this on, we've got 5, 6, 7, 8, 9. So let me kind of extend this out. Sorry, it doesn't look very good. 5, 6, 7, 8. Wait, no. 5, 6, 7, 8, 9. Okay, so then I'm going to draw this point up here. Okay, and it should give us a value of 4. Okay, all right, so we are good. Now, what we want to do is we want to find the average rate of change. Okay, so this is and when it says average rate of change, I always think slope between 2 points. Okay, but the difference is between 2 points. Okay, the difference is that, you know, if I take these 2 points here and connect them with a line, all right, I want to find the average rate of change. Well, I can, you know, go up 1 and over. Okay, so I go up 1 and then over from 4 to 9 is a measure of 5. Okay, so my average rate of change, my slope is going to be 1/5. Okay, that's my average rate of change between those 2 points. Now, I want to use this f of b minus f of a all over b minus a. Okay, the slope formula. All right, and here's what I've got. Okay, I know that my interval, okay, goes from 4 to 9. That means that a is equal to 4 and that b is equal to 9. Okay, now remember that these are x values. Okay, so if I wanted to find the y values, then I would find f of a, which is f of 4, okay, which is the square root of 4 plus 1. Okay, so I get f of 4 is equal to 2 plus 1, which is equal to 3. So f of 4 is equal to 3. And then if I wanted to find f of 9, okay, that's going to be the square root of 9 and then plus 1. So I get the square root of 9, which is 3 plus 1. And so then f of 9 is equal to 4. All right? So here's what I've got. If I wanted to find the slope, m, okay, I would take my y value here, this 4, minus my 3, okay, these are y values, and divide it by subtracting 9 minus 4, okay? And so what I end up getting here is I get the value of 1 over 5, okay? And that's my average rate of change. So saying, you know, however you guys want to do it, doesn't matter, but that's the idea, all right? So, okay, let's just find the coordinates. We already figured this out. We already did it. Don't worry about it. We got 1/5. All right, we did it up here. All right. And company sales, we already found that one. And we want to find, okay, last question. Which graph shows a function that always has a negative average rate of change, okay? And so if you take 2 points, okay, what I notice here, if I take those 2 points and find the slope between those two, that's positive, all right? But if I did this over here and here, we get negative. And, you know, that's the thing, is that you have both positive and negative. We want to figure out which one of these functions always has a negative average rate of change. So if I take any 2 points here, okay, any points along this function, what I notice if I connect those are always negative slopes, okay? So this is the answer that we're looking for, all right? So, you know, you guys have done slope before. It's just we're kind of, you know, giving it a couple new names, calling it, you know, rates of change, average rates of change, and we'll kind of explore this for a while. So I hope you enjoyed this video, and we'll see you soon. Thanks. Bye!